All right, wave.
Hi.
All right, hi everybody.
Hi.
Yay. Awesome.
Oh,
What?
oh, hey.
Oh, so we're on. Okay, sorry.
Yeah,
I was having
yeah.
too much fun. I wanted to zoom there. So I'll just tweet that. You talk. I'll
Oh, okay,
tweet.
all right, yeah. I just say, yeah,
Okay.
you talk. All right. Well, over there, tweeting away our little picture, and you can
Hi.
check it out there momentarily at
Hockey Geek Girl.
Hockey Geek Girl.
And Geek Trainer.
And Geek Trainer here is Susan Aback. I am Christopher Harrison, and this is Introduction to Programming using Python. And I guess I'll just take it from here.
So are you talking? Yeah, sorry.
No.
Okay, go.
Up until now, what we've been doing has been focusing in on the little components that you're going to use to make your program. And in fact, we actually saw in the little chat window, somebody mentioned that they felt a lot more confident about going in and solving simple problems, which is awesome. That not only does that make our day, but that really was the whole goal here. Now what we want to do is kind of take what we've done and take it to that next level to kind of show one more component that you're going to need to start to write more complex code. And what we're going to need in order to start writing more complex code is simplify the basics. So rather than always having to say open every single time that I want to open up a file, let's go ahead and just create a function that will automatically take the name and give me back all the text inside of it. And so I've sort of given everything away by introducing the name function here, but let's start talking about what a function is going to do for you. Repetition. One of the problems that you're going to notice with code is that you're having to do the same thing over and over and over again. The same few lines of code, the same operations, again and again and again. One of the problems with code that you're going to notice is that you're frequently doing the exact same thing over and over and over again.
I'm not sure I got that, Christopher.
The same few lines of code, the same tasks, the same operations. Let's go to the next slide. So one of the problems that you're going to notice, in case you haven't picked up on it, what we're looking to do is avoid that repetition. Just like, nobody likes listening to somebody who's being repetition, nobody likes to see code that looks like that. That code with repetition is just fraught with problems. That not only is it now that I have to keep going back in and copy, paste, but one of the points that Susan made earlier very well is if you have to change a value somewhere, you then have to run around to all of those different spots and keep changing it over and over and over again. And while certainly, yes, variables can help you out there, it's nice to have a black box. It's nice to have some balled up block of code that I can just toss in a couple of parameters and then just poof, it gives me something back. Basically think of it as a bread machine, if you will. That I've got my bread machine, what's it going to do? Well, it's going to bake bread. Well, what I can do is I can throw in rye and all of that, and now I get rye bread, or I could throw in cinnamon and raisins and all the ingredients, and now I get back cinnamon raisin. But all I'm doing is I'm just simply tossing a few ingredients into a machine, I wait for a few hours, and then voila, I have bread. That's what a function is all about. It's your bread machine. That what I'm going to have is some little box that I can toss a few items into, and it will automatically do work for me, so that way I'm not having to do the nitty-gritty. I'm not having to knead dough. I'm not having to punch it down, although that can be a great stress reliever. But I'm not having to do that. I'm just letting the machine do it for me. That's exactly what a function is. So what if we could just create a button that does the work and then just press that button?
And it's nice and sort of self-contained, right?
That's it.
I like it.
Yep, that's exactly it. That's exactly it. So let's talk about functions. Now, what is a function? I think the simplest way to put together a function is sort of define it in English. It's a noun. It's a reusable section of code that has a name that does something. And the big point that I want to make here is that what it does is sort of irrelevant. That what it does can be all the different things that we've already learned to do. So Susan did an example earlier about reading a file, and she automatically read the entire file into contents, and we saw that that took a couple, 3 lines of code to do. So what I could do is I could just create a function and say, read file text. give it the name of the file that I want, and it will just simply give me everything back. Or maybe I say print file text and give it the name of the file, and it will automatically print it. Whatever it is that you want it to do, you're going to notice that the content of that function is going to be code that we've already learned. Now, the most important point to me, or I should say the point that's often overlooked when it comes to functions, is this part right here. The ability to give it a name. So if I created a function and I called this function print file, like that, and then inside of here I had code, and that's all of the code to go in and print that file, I don't need to know necessarily what's going on inside of all of this, because if I look at this, that says print file. What do you think that's going to do, Susan?
I think maybe that will print a file.
Absolutely. And so kind of going back to that whole comment conversation, comments can oftentimes be a smell that, yes, do comment, but every now and then, all that you're doing is explaining something that maybe could be simplified. So rather than putting in a comment, this is the code that will print a file, create a function. Give it the name, print file, and then now you don't necessarily need that comment.
And you know what?
On top of that,
if you look at all the things we've been calling, all the functions we've been calling, somebody wrote the function read that we were using to read files earlier. Somebody wrote the function print that prints things out for us. Those are all functions someone else wrote for us.
Absolutely.
We don't know how they work. We just call print when we want to print something on the screen. We call read when we want to read the contents of the file. And because they've got good names, the code is hidden from us. For us, it makes life easier.
Exactly. And actually, this is sort of funny that I keep stealing your thunder.
I just stole yours.
Digging into
sorry
your
about
slide.
that.
Yeah, turnabout is fair play. And actually, again, this is sort of perfect because it's a great validation that we're moving in the right direction. If we take a look here, the next part of the slide, you've already used functions. You've already used print and open and write and close. And here's the thing. I've been developing for years.
Yep.
That might have gotten garbled.
Yeah, it's an audio issue.
Yeah, exactly. Must have been an audio issue.
Yep.
But I've been programming for many, many years. I'll be honest. I have no idea how to make a call into the Windows APIs and open a file. I've got no clue. Why? Because every single programming language, every single environment that I've ever used has provided a wrapper for all of that. So all I had to do is just simply say, open, or open file, or something like that, and it automatically made the calls behind the scenes for me. It automatically read the ones and zeros off the disk. I didn't have to do any of that. And I didn't need to know how to do all of that. How that happens behind the scenes, I've got no clue. But can I do my job? If the task is read data from this file, can I perform that successfully? Absolutely. And I don't need to know how things work underneath. And that's the whole goal of a function, is it can help simplify things. I'm taking away the stuff that I really don't care about. I'm putting it over here. I'm just giving it a bigger name, and then just calling it. And again, kind of going back to the bread machine, I have no idea how a bread machine works. I don't need to know. I just put in my ingredients, I hit start, and in 3 hours, I've got bread.
Yep.
So, you love your bread machine, don't you?
I do. I use our bread machine all the time. And I love several comments of when you slice the bread and put it in your free toaster.
Yes.
It's been coming up in the comments. And I also want to specific call out to the person who suggested with Marmite, because Marmite, some of you may have heard of Vegemite. There was a song, She Just Smiled and Passed Me a Vegemite Sandwich, which made Vegemite famous.
Yeah.
The British equivalent is Marmite. I actually like Marmite. If you've never had it, most people think it tastes absolutely disgusting. So I'm happy shout out to that one lone person out there as well who also likes Marmite. Moving on.
You found the one person that likes
I found the other person who likes Marmite.
Well done. All right. So then why create functions is exactly what we've just said here. So code reuse. You are going to be doing the exact same thing over and over again. Simplify your code. So rather than having, a big comment or a big block of code that requires some level of interpretation, you can just create a function. And it can also help break down your code that, a lot of times you're going to be dealing with multiple things that maybe what I need to do is I need to collect some user input. So, maybe that's going to be a bunch of input statements, but instead I create a function. So I'll say collect data from user. And then I create that as a function somewhere else. And then now I need to write that out to file. So I say write data to file. And again, that's created somewhere else. And so now when I go in and I look at this, that's pretty simple. That I know exactly what that's going to do in English. And if I need to go in and take a look, then I could go do that. But a lot of times, just that high level, that's all that I'm going to need. And then finally, last but not least, is it is going to make it easier to make changes. That let's say later on that instead of writing out to a file, I've decided that we are going to write out to a database, or maybe what I want to do is write it out to a file and write it out to the screen at the same time.
Sure.
I only need to update that in one place rather than going around to the 8 places where we've got that same bit of code. So why create functions? Because in the long run, this is going to make your life easier. This is going to make it easier to do the most important thing. If you've learned nothing else this week, the most important thing about being a developer is to be a lazy developer. Lazy coders. For good functions will help make you a lazy coder. All right. Well then, how do we create a function? So, first little part that we're going to need is we're going to need keyword def, which is short for define.
Makes sense.
Okay. Next part right here is going to be the name of the function. Now, the name of a function is extremely important because this is now what you're going to keep using over and over and over again. So we were talking about variable names earlier, and when you're choosing good variable names, you want to make sure that it's nice and clear, that I can look at that and go, okay, I know exactly what's going on there. Cool. Well, I want the exact same thing when it comes to functions, that if I can look at a variable and figure out, oh, okay, well, that's the piece of data that it's calling, I need to make sure that when I look at a function, I know exactly what it's going to do. Because if I look at a function and I go, well, I don't know exactly what that's going to do, and I then have to go look at the code, I've sort of failed a little bit there. Yeah, that now I've defeated a bit of the purpose, because a bit of the purpose is to not have to go look at that code unless I explicitly need to know that maybe I need to do a little bit of debugging, or maybe I'm just curious, hey, you know, exactly what is it that it's doing? But if I have to look at it to figure out what it's doing because the name isn't clear, that's a problem.
Yeah, we should be able to do better.
Exactly.
Yeah, we want to make this, one of those things so that we don't need 22 lines of comments to explain something whenever we call it.
Exactly. Yep. That's exactly it.
So now, can we talk to the guys who built STRPython?
I'll work on that. Now, the next thing to note here, and I'm putting this on the slide just for kind of full disclosure, you'll notice that you can also set up parameters. We're going to talk about that later. So okay. I promise you, we're going to have that. And then finally, last but not least, is you put the body of whatever it is that you want it to do tabbed in, and then finally, you're going to notice a return statement right there. Now, what return for right now is going to mean is it's just simply going to mean exit. It's going to denote the end of the function. Return can mean something else, which we'll talk about in a little while, but for right now, kind of keeping things simple, it's just going to be exit. Awesome. So now, the question becomes, well, how do we call it? Well, the way that we call it is really the exact same way that we've called other functions. That if you remember calling open, if you remember calling print, all that we did was name, parentheses. Name, parentheses. That's it. So if we take a look here, you're going to notice define print message. Print message. Done and done. That's it. Let's do it.
Yeah, I want to see it live. Because one thing on a slide, I sort of get it, but it makes more sense when you actually see it running in the code. Somehow that makes more sense.
100%. Okay. Let's see. This is module 13. Functions. There we go. Okay. So, little coding thing.
Okay.
If you're putting a whole bunch of things into one file, and you're putting your functions into that same file, one of the things that you'll want to decide is kind of where you want to put everything. And typically, I like having my functions down towards the bottom. And the main reason for that is just so that way I can kind of more easily focus in on what's important and worry about the other functions later. So I can go in and say, for example, like define, and we'll just say print message. And there we go. Whoops, don't forget your colon, Christopher. And let's just go ahead and say print and hello world. Got to start out with hello world. We'll say return, which is spelled with an N today.
I feel like it's nice. It's sort of almost feel like we're coming around to beginning again. Hello world comes back.
Exactly. Hello world comes back. And then you'll notice right up there at the very top that I've got my print message. Now, this is, and I swear to you this is true, this is an on-purpose error.
Yep. I had a suspicion you were going to do this one.
I did this one on purpose. One of the things that we've been highlighting an awful lot is differences between code. And depending on the language that you're in, sometimes you need to define things earlier, sometimes you can define it later on. Here, what you're going to notice, if we kick back to my code here, is it's going to tell me print messages is not defined. Control-P print, can't find printer. It's right here. So my... I'm just going to keep quoting a comedian.
Go ahead.
But in any event, what you're going to notice is we've got print message. It's right here. But the problem is that we put the calling up top.
Yep.
And we defined it down below.
So it's a little bit like when you try to reference a variable, in the wrong order.
Exactly.
You can't reference a variable and then create it later. This doesn't really make sense.
Exactly. Yeah, and that's a perfect way to put it. That's a perfect analogy, is that you can't define a variable later on and then use it earlier. Same thing here. And so now, if I reorganize my code, which I just did real quickly behind the scenes, you're going to notice that now this prints out hello world. So again, I'm going to stick with it. Kind of keep all your code block together. And like I said, typically I would like it down at the bottom. Not able to do that here. Not a problem. Just put it all up at the top and then go ahead and define everything down below. Now, another little trick that you could use to get around this, and you see this an awful lot, is to maybe go something like define and then main. And main in a lot of languages is a keyword.
Okay.
That main is how you start a program. And so what you're going to notice is I've reworked things, and this is actually going to work out really well. So I'm doing two things at the same time. The first thing that I want to highlight is you're going to notice that I created this brand new function up here, and I called it main.
Okay.
Now, main, again, this is in a lot of other environments, is the standard entry point. So Java uses it, .NET uses it, I'm pretty sure C++ uses it. I don't want to admit how long it's been since I've done C++. So, but I'm pretty sure if I remember right, C++ does it, and so forth. So all that we're doing is kind of sticking with that convention. So you'll notice that I created a brand new function here that I've called main, and then you're going to notice that I called one function from another.
Yep.
Now, I'm highlighting this, but if you stop and think about it, this shouldn't necessarily come as a huge surprise, because, Susan, what's print?
Print's a function.
It's a function. So when we did our print message, I already called a function from a function.
Yep.
So it would stand to reason that I could call another function from a function. Now, again, you're going to notice that if I go in and I hit start, that now it behaves a little bit differently. You'll notice that now this is working.
Yeah.
And you might be thinking, well, time out, Christopher, hold on. Hold on.
It looks like you still are calling it before it's declared.
Exactly. It looks that way. But I'm not. And this is a very big point. When you define a function, what you're doing is you're saying when somebody calls this function, this is what I am going to do. And notice my conjugation there. Notice the tensing. This is what I'm going to do. Not what I did, but what I'm going to do. So and if we come back to the code here, when I called main, what I'm doing right now is I'm saying execute the main function. I don't need to shout. Execute the main function. That's what I'm doing. I'm explicitly stating I want to call that main function right now. And in order for me to do that, In order for me to do that, the function must be created.
Aha, and it was. It was created before you actually called main, that you could see the function defined before you actually called it.
Exactly. Now, when I define a function, what I'm doing here is I'm saying define this function. When someone calls this function, execute this code. So again, you're going to notice my tensing here that when I define the function, I'm going to wait until somebody calls the function to execute that code. So future tense.
Yes.
So what's going to happen is the Python parser is going to read through all those definitions, kind of put them into memory, as it were, and wait for somebody to call them. So nothing inside of here is actually being checked until we go in and call it. So that's why I could get away with print message.
Yep.
And so now I've gotten to the scenario that I kind of like, which is this is the body of my program, of my script, of whatever it is that I'm doing, and then down below are all of my method functions, and then down here at the very end is what's kicking it off. So, if I added another comment,
you're not actually executing any code until you reach that line that says main all by itself.
That's exactly it. That's exactly it. Okay, I'm going to take a drink.
Okay. Well done.
Thank you. I kept waiting for a good point when you were going. But
you were hoping me to go a little longer.
Yeah, exactly.
No, my
keep
apologies.
Talking, keep talking.
You've had your drink now. Now I'll let you go back.
Okay, perfect. All right. So there is the basics of how we're going to go in and define that function. Now, in my case, I've kept it relatively straightforward, at least as far as the bodies go, that you're going to notice that all I did was just simply print and then hello world. And I drank too fast, so I need to. There we go. Sorry about that. Okay, so you'll notice that I kept it very simple, that I just went with print and hello world. But could I have also done, maybe something like this is let me call this print names, and maybe call this print names, and then we'll go ahead and say names equals, and then we'll say Christopher, and we'll say Susan, and we'll say Danny, because I'm going to get his name right, which will make him very happy. There we go. And then I could go, I could say for name in names, and don't forget your colon, Christopher.
Don't forget your colon.
And then I could go ahead and say print name. So could I go in and do something like that? And the answer is 100% yes. And of course, if I hit start here, you're going to notice Christopher, Susan, Danny.
Yep.
Cool. So it's doing exactly what we think that it would do, that really this block of code right here, there is nothing that we haven't already learned there. So can I open a file? Could I, parse CSV? Could I, write to a database? Whatever it is that you want to be doing, the answer is 100% yes. That if you can write it in code, you can put it inside of a function. Awesome. All right. Now again, just to kind of highlight this, the one nice part about all of this is that all I have to do is I just have to say print names. I don't need to know what's going on inside of print names. I now know it's going to print the names.
Though I will point out one thing.
Yeah.
Since you created this function, obviously at some point you knew exactly what was going on inside that function.
That
right?
is true.
So you say, I don't need to know.
I knew,
but the nice thing is once you have created that function, you can almost forget about it.
Yeah, exactly.
But when you create it, you have to know what's going on.
Exactly, yeah. And when you start to get a bit more advanced, you're going to start to create your own little helper libraries and maybe share those out with other developers, so they might not know what it is that you've done.
Yes.
So yeah, absolutely. Yeah, I don't have that short term of a memory. My memory is really short, however. Okay, cool. So anyway, so there is our little functions there, and kind of how we can break all of that down. Awesome. Now,
you know what? Actually, can I suggest one of my favorite functions that I always like to write for myself?
Please.
I like writing a function that will format dates the way I want them. Because that we talked about that syntax for that string f time and the %b's and all that is so confusing.
Absolutely, yeah.
And it's something I hate looking up. And I find that when I'm working with dates, 99% of the time I want it displayed the same time because it's for the same group of users and they want it the same way. So one of the functions I often create for myself, one of the first ones I end up creating, is a function that will display a date the way I want to.
Yep. Exactly.
And that way, once I've done that once, I kind of forget about writing out how you do the strf time thing all the time. I just call my function when I need it.
Exactly. And a lot of people were asking earlier about, looping through through an array and maybe finding every particular item and if it, getting rid of duplicates and things like that. Well, this is exactly where functions come into play, because could you do that? Absolutely. You would just take a loop and you go through and eliminate your duplicate. The problem is that, it's going to be, a few handful of lines of code. That's perfect for a function, because then I could just create a function, call it remove duplicates, pass in my list, and then let it do its thing. Ooh. Pass in its list.
Oh, and I need that for my date functionality too, because I'd have to let you pass in the date.
Absolutely.
That's going to be, and it would have to give me back. So you'd have to pass in the date you want formatted, and the function would have to give you back the nicely formatted string. So
Exactly.
You're right. I need, and it actually already came up in the Q&A. As you can imagine, someone's going, hey, how do I pass a value to that function? So I'm glad we're there.
Yeah, exactly. Because if you look at the bit of code that I've got here, the only 3 names that this is ever going to print is going to be Christopher, Susan, and Danny. Period. End of sentence. That's it. So what happens if we want to be able to maybe allow somebody to pass in the group of names that we're now going to display out? Well, that's exactly what we're going to get into. So I'm going to go back to my slides here. There we go. Okay. So we want the functions to be more dynamic. Now, the functions that we created were good because they did one thing, and sometimes that's all that you need. But sometimes we need a bit more flexibility. So maybe we need to pass in a parameter about whether or not we want to set up custom messages, or maybe 2 numbers to perform a calculation, or maybe we want to write it out to the screen, but optionally write that out to a file as well. Wouldn't that be nice?
I like it.
And that's exactly where parameters come into play. Now, here's the thing. Parameters, fantastic Scrabble word, if you can, fit that on there, is a very fancy word for a concept that we've already played with. A parameter is going to store a value. Hey, Susan.
Yeah.
What have we already used for something that would store a value?
A variable?
A variable, exactly.
All right.
So what's a parameter?
Do I get a point?
You get a point. You got a gold star today and you get a point.
I'm having a good day.
Well done. We'll have to figure out how you can cache those later. In any event, so a parameter is really nothing but a specialized variable. It's a variable for a function. And what's going to happen is, rather than saying, like we did in the past, variable equals whatever we want the value to be, we're going to wait for somebody else to give us what that value is. So it's just like a variable. And in fact, we've already used parameters. That, remember when we said print hello world?
Yep.
Parameter.
Yes, true. I was passing a value to the print function.
Exactly. That's it. So we could actually update our little methods to accept parameters. So I give you an example here. Print message, give me the message. And then all we're going to do is just display it out with print message. Now, while we're here, you might be looking at this and you might be thinking, Christopher, you're keeping things relatively simple. And you know what?
Those are very simplistic
right.
examples.
Yeah, you're 100% right, because I'm focused in on creating functions. But I got to tell you, so many of my functions are really actually 2-3 lines long, and that's it. Because sometimes even just that little bit of cleanup can make a big difference, especially if I'm doing the same thing over and over and over again, or if we've kind of poked fun at strf time. If it's not overly clear, creating your own function, like Susan mentioned earlier, can make life that much easier. So don't be afraid to create a function that's only 1 or 2 lines long. If it's going to simplify your code, do it. Don't be. There is no minimum number of lines for a function. I would say, however, there is a maximum in that if you have to scroll up and down, your function is probably too long, that it's probably going to be trying to do too much, or really, more practically, it's hard to read. That if you're having to scroll to read through a function, especially when you're trying to debug it, that just winds up making it that much harder to try and debug. So really limit yourself to one screen per function.
Function does one thing.
Exactly.
Don't write a function that does 20 different things. Write a function that will open the file you're planning to use. Write a function that will take the contents of the file and return you all the animal names from the file.
Exactly.
You know, but don't try to write one that will open the file, get all the animal names, do all the error handling for that, and close the file and take the results and print them on the screen. That point, that's your program.
Yeah, exactly.
Yeah.
So what you would do is you take each individual component of that, break that down into different functions, give those all good names, and then go ahead and call them, and that way you could stack them from there, and it makes it that much easier. You know, don't create a function that's going to take in a parameter and figure out, okay, well, we're going to write to a file, or we're going to write to a database, or we're going to write it up to Azure, or then you're just making your life difficult. Okay, so with that, let's go in and kind of keep going with our parameters here. What about multiples? Well, you could absolutely add in multiple parameters by just simply separating them out with commas. That's it. So just simply define display message, greeting and name, and then just simply concatenate that together, and then you'll notice that we can just print that out like that. Cool. Let's go in and take a look at a demo here. So let me open back up Visual Studio. So here's what I'm going to do is I'm going to, right up here, I'm going to, give me your names. There we go. Let's put our names right up here. And I'm going to say new name equals input, and let's say enter last guest, like that. We'll say names, append, and then that new name. And now here's what I want to do, is I want to print out those names, but you're going to notice that I, in my case here, have put together my names up here.
Uh-huh.
That's what I've done.
Yep.
So what I want to be able to do is I want to be able to take those names and send those down there.
I like it.
This is where a parameter comes into play. So what I'm going to do is I'm going to create a parameter that I'm going to call names. And then up here, I'm going to say print names and then pass in my names. Now, a couple of things that I want to point out. Number one is what's going to happen behind the scenes. Actually, before I get there, I'm going to call it list for right now.
Okay.
Okay. Just because I'm going to try and avoid confusion, then I'll step back.
Sure.
So here's what's going to happen. Names is automatically going to be passed into there. So it really is almost as if behind the scenes I said list equals names.
Okay.
It's almost identical
Sure.
to me doing that. So just like a variable, but I just don't have to say name equals and then whatever the value was. That happens automatically behind the scenes.
So the value that I specify when I'm calling it gets put into the variable name that's used in the function.
Exactly.
Okay.
That's it. That's it. And so now, let me go in and start this. And you'll notice that it will ask me for my, my last guest. Let's invite Satya.
Oh, yes.
Hit enter, and sure enough, it displays Christopher, Susan, Danny, and Satya. Cool. Now, I want to go back to what I did a second ago, where I had this as names. And you might be looking at that, and you might be thinking, well, wait a minute. You already used names.
Christopher?
Yes.
I'm confused. I've got the variable name names inside main, and then I have another variable name names inside print names. I'm confused.
Good. Well, not necessarily good, but let me help. One of the interesting things about functions, and I do have a slide on this, is functions also serve as a container. By the way, the big fancy technical term for this is scope.
And we actually had somebody say, maybe you guys should discuss scope, actually popped up in the Q&A. I said, we're not going to get too deep into it.
No.
Because we don't want to get too far, but
Exactly.
we just touch on it here.
Exactly, yeah. Because scope can become very complex really quickly. So what I'm going to do for right now is just kind of define it as this. Our functions create containers. Our containers define what's known as a scope, or more simply, a variable's lifetime. So if I declare a variable as a parameter or inside of a function, once we get to the end of that function, all of those variables go away. So after this, names is now no longer available. Or after this, names is now no longer available. So you'll notice that I can reuse the same, forgive me, name.
You know,
now,
it's a silly analogy, and it's not entirely accurate, but sometimes the way I think of it is I think of when you're inside Windows Explorer and File Explorer, you can have the same file name in 2 different folders.
Yeah, exactly.
And, you know, when you're in this folder, that file
analogy.
name contains the contents that it has in that directory. And if you have the same file name in a different directory, you can have completely different contents.
Exactly.
So it's kind of like that. One function is one folder, it can have the name, and another one can have the same name.
Exactly. And you might be looking at all of this, and you might be thinking, well, you know, Christopher, for me, using the same names is a little bit confusing. And I could certainly see how that would be.
Sure.
But the couple of things that I want to mention is, number one, I mean, if it's a group of names, you may as well call it names. But not only that, if you're trying to make all of your variables uniquely named across your entire application, after a while, you're going to run out of names. You're going to run out of creative, A names, B names, C names, you know.
I have seen people, one thing I have seen that isn't too bad if it does bother you, is I have seen people who will do P_name or P name when it's a parameter.
Yeah.
So they'll do that as the parameter, so they remember that anything which is P names is the parameter that they define for the function. So that's the only, if you really feel you have to do it, that might be a compromise.
Yeah, exactly. Yeah. Exactly. Yep. So you'll notice that sure enough, this is now going to keep on running for me. Excellent. So now let's kind of keep on keeping on here. I'm going to go back to my slides, and let's break things down into returning data. So up until right now, what I've done is I've created functions that went off and did something for me. They wrote something out to the screen, which can certainly be, again, exactly what I'm looking for. But again, it's relatively limited because the only thing that it's going to be able to do is print out. What happens if I want, again, a little bit more flexibility? That maybe I would like to create a little function that can start prompting the user for the collection of names. And then once they're finished with entering in all of the different names, it will just give me that collection of names back. And then I can decide what I want to do next. So maybe I want to print it out. Maybe I want to write it out to a file. So I would have that option there because it will give me the value back.
And I would need this, I keep coming back to my date formatting challenge, right? I said one of my favorite functions to write is I will write a function that accepts a date value as a parameter, and it returns a nicely formatted string with the date formatted the way I like it. And that way my little function has all that str, p time, percent, whatever in it, but I just call my function that says format date.
Yep.
I pass it a date, and it gives me back a string formatted the way I like.
Yep.
And if my users ever change their mind about the way the date formatted, I just go change one line in my function, and I'm done.
And you know what's kind of funny here is I'm now regretting the challenge that I put together, that I really wish I would have put a challenge together of create a function to better format dates. I should have done that.
Let's make that the extra credit.
There we go.
That's
There's
going to be your extra credit
Yep.
challenge. I like it.
All right. In any event, let's go in and kind of take a look at how this is going to look. And what you're going to notice, take a look at how it's going to look. What you're going to notice here is we've had our return before, and what return meant until now was exit. Well, now what we're going to do is we're going to use return and give it something. And what that will do is that will then send that back out to whoever it is that called it. So if we kind of break things down, you'll notice that down here I've got my little get message. So I'm going to pass in Christopher. It's going to do its work. And then message, sound effects and all, is going to go right down to there.
Nice.
So that is what's going to happen with our return value. Now, before I go back and do my demo, you'll notice there's my slide on scope. It came up earlier than here. But again, you know, after a while, you just can't always use different names. And again, you know, it's...
You can use the same file name in 2 different folders.
And sometimes that's what you need.
Yeah.
You know, keep using the same name when appropriate. Okay. let's go ahead and take a look at how we can return back values here. So I want Visual Studio, and let's say I'm going to do this. I'm going to, let's just say def, and get names.
Okay.
There we go. And don't forget your colon, Christopher. Let's just paste that into there. Okay. Now, for right now, I'm going to keep it a little bit simpler on myself. That you're going to notice that I'm just going to keep the exact same code that we had before. And then right here, I'm going to say return names. Now, you're going to notice I can return whatever I want.
Yep.
So I could actually return, Christopher, I could just return a string. If we had a date time, I could return back a date time. We could return 42. So the fact that we're returning a list, sometimes people look at that and go, well, wait a minute, that seems, a little more advanced, because a list object is inherently more advanced. A list is more advanced than a number.
We saw that in the last module when we were looking at reading files.
Exactly. But you know what it is at the end of the day? It's still just a variable.
Yep.
So it's still just an item that I can pass around, so I can still return it just like I normally would. And then you'll notice that what I could do is I could say names equals get names. And now we're going to get the exact same behavior that we saw before. So now let me go ahead and hit start. Enter last guest. Again, let's go with Satya. We'll hit enter. And sure enough, there's Christopher, Susan, Danny, and Satya.
Cool. Do you know what? Can I make would you like to just take a second and maybe step through that code with the debugger so they can sort of see how it's hopping into the functions in the order of execution? Sometimes that's sort of interesting when you've got functions.
Okay. So what you're going to notice, I threw in the breakpoint here, is right now we're stopped on names equals get names. And so what I'm going to do is I'm just going to hit my little step into here, and you'll notice where that little yellow arrow is. You'll notice that the little yellow arrow is now inside of get names. Why? Because that's what I called. So I called get names, and so it automatically threw me into get names. So now what I'm going to do is I'm going to step down one more, and now we've got our new name. Now we're going to go ahead and get the last guest. Let's go in and again add Satya. He doesn't return any of my emails. The
thing is, he probably would return our emails if we asked.
Might, exactly.
So we shouldn't say that. For all we know.
You're right. Yeah, I shouldn't say that.
I've never tried.
Never emailed them. It was really an attempt at humor there. Most of these jokes are just for my own entertainment. In any event, let's go back to Visual Studio here. And so now we've got our little append and then return names. Now watch this. When we return names, I want you to watch where the arrow goes. The arrow now goes back up to here. So now we're back inside of main. Let's go down one more step. Now we're at print names, and then now you'll notice when I go into print names that it's down there on print names, and now we've got our for loop and away it would go from there. And so I'm just going to kind of skip to the end, and you'll notice that it's printed out all the names.
Cool.
Perfect. Okay. Now, the last little thing that I just want to mention here, because I'm willing to bet this has come into the chat window, and if it hasn't, then I'm going to do it anyway. One of the things that Zoomit can do is put up a break timer, as we've seen. So one of the other things that you could do here, get names, is just like before, you can call one function and add in another function. A lot of people were asking things like, well, could you do meaning of life equals int input, what is the answer, boom, 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 like that. So a lot of people were asking, could you go in and do that? And the answer, of course, was 100% yes. So could you do this? And the answer is 100% yes. That what you'll notice right here is paren and paren, that the parentheses are going to identify, kind of do this first. So the outer all the way to the inner. So it's going to, or other way around there, but it's going to call that get names first, and then it's going to call print names second. So you could absolutely do that. And whether or not you decide to do that is really up to you, that you really can start to get kind of fancy here, that if I maybe wrote a method that looked a little bit like this, maybe something like def get message name, could I go in and say return :
Yep.
topic, if I go in and say return hello and name, is that going to work? Absolutely. That you could go in and define that in line. And whether or not you decide to break things down into different variables, into different steps, is 100% based on your own comfort level. That I know a lot of advanced developers who will never do something like that, who will never do a calculation on the return line, that they will always create a variable and return the variable. Hey, you know what? If that's what makes sense to you, if that's how it's going to fit, go for it. 100%. Yep. Cool. Huh. Awesome.
You're rocking.
So, I want to close all this off, and here's my challenge, which the date one would have been a little bit better.
It's okay. That's going to be the extra. So the extra. So the extra credit challenge is going to be write a function that accepts a date. And returns a nicely formatted string that shows a date the way you like to see dates displayed. So that's your extra credit challenge.
There's your extra credit challenge.
Now,
Here's
Christopher has your regularly scheduled programming challenge.
Exactly. So the regularly scheduled one is, and what the whole thought process behind this was really kind of the point that I kept trying to make over and over and over again as we went through all of this, which was, the whole goal of functions is to try and simplify things, is to try and make reusable blocks of code that you can just kind of keep going back to help simplify things. So imagine a scenario where all you want to do is write some data out to a file. So what are you going to need? You're going to need two things. You're going to need the data, and you're going to need the file name. And could I sit down and write that in a bit of code? Sure. But you know what? If I put that inside of a function, then all I have to do is call that function. And that's exactly the challenge here, is create a function to simplify writing to files. Set it up to accept parameters, one for the text to write, one for the name of the file, and then of course add the code that's going to write the text out to the file that was specified. And you know, if you wanted to, now you could start to get all crazy with the cheese product that comes out of a can, and maybe start adding in input statements where you could then prompt the user, give me the text, give me the name of the file. So you could really take this and kind of keep building upon this. But again, the main takeaway that I want you to get, the whole goal, is that it's there to help make your life easier. So what we've seen, the congratulations slide here, is you now have the ability to save yourself some time by putting those statements into functions. It's going to simplify your code, it's going to simplify debugging, it's going to simplify your updates.
Absolutely. And in the end, it's going to allow you to be a better lazy programmer.
Absolutely.
Awesome.
Now, I don't know about you, Susan, but at least periodically when I write code, something goes wrong.
I would say never, but I think I'd be struck down by lightning.
Yeah, and in fact, both of us have had things go wrong.
You've seen us have things go wrong right here
there's video
in our demos.
evidence of us.
So I think what better way to wrap up our day than by talking about what can we do when we're coding to deal with things that go wrong in our code, so we don't just get nasty error messages spewing all over the screen, and how do we deal with those? And I think when we're done that as well, I think we need a little more homework.
Okay. Yeah, more homework. All right. With that, let's go ahead and take 10, and we'll come on back with the last module of the day. Stick with us.
See you soon.